Hi everyone. So I think we do have few people who have joined us now. So let's start our session. So good afternoon and warmly welcome you to our webinar series MLOps Simplified. It is a part of uh, an insight webinar series conducted here at Octave, and we warmly welcome you all today. And thank you very much for have spared your precious time. I know probably right after lunch. So thank you very much. And we are delighted to have you here on our session today. Prior to starting the session, I would like to request our audience to kindly turn your mic on mute in order to avoid any disturbances while the session is being conducted. So, uh, to start off, today we will be diving deep into the dynamic world of machine learning ops, where cutting edge technology meets operational excellence, and we will be discussing on the essentials for practical machine learning success. Whether you're a tech enthusiast exploring this field or a seasoned professional seeking to enhance your ML workflows, you're in the right place today. So, throughout this webinar, we will talk about real world expectations of ML ops, discussing best practices, challenges, and the latest trends shaping this landscape. So, buckle up for an insightful journey into the heart of machine learning ops, and we are here to explore on how this transformative field is reshaping the way we approach and deploy machine learning models. So I have to be transparent. I myself is very new to this space. I come from a very different background, completely opposite to technology, and I am a very recent recruit at Octave. I'm very excited to be here, and I'm looking forward to be part of this session as well. Um, so I'm not going to take a lot of time at the interest of time. So without further ado, let's get right into it. For those who are new in this space, I'd like to give a very brief introduction on who we are and what we will be doing here at Octave. So Octave is a subsidiary of John Keel's group, as most of you are aware. And we are a pure play advanced analytics company dedicated in delivering measurable cash flow impact by deploying advanced analytics solutions that solve real world business challenges. We also have a very dynamic team here at Octave, and we are very proud to have some of the top industry professionals in the data science and engineering sphere in Sri Lanka working at in the Octave team. So from that team, we have two esteemed panelists joining this conversation today to share their journey and expertise in this field. Let me not take up too much time here at the interest of time. I would like to hand over this session to Liam. He is one of our lead data engineers at Octave with a very impressive work experience in the field of MLOps, and he will be taking you through few fundamental concepts of MLOps. Again, prior to handing over the session, I would like to request the audience once more to kindly ensure that your mic is on mute. If you do have any questions that you may want to ask during the session, please be good enough to kindly send it in through the chat. So we will get into it when we come to the Q&A session at the end of the webinar. So over to you, Lean. Maybe you could give a brief introduction to our audience on your expertise and in this field, and let's start this conversation from there. Over to you.
Thank you, Shami. Good afternoon, everyone. Thank you for turning up just after lunch. So I have been in Octave for closer to 6 years now, currently working as a lead data engineer here. With the growing number of use cases or projects that Octave has encountered with, we realized that we wanted to operationalize some best practices. With the growing number of employees and projects, we could not cater to the demands of the businesses without a proper process. So that's where MLOps practices started back in 2020-21. Now I think the organization has grown up and the practices also evolved. So with that, Shalini, let's move on to the session. I'll be taking the first 30, 40 minutes. We'll give you an understanding on the core concepts. Later in the session, my colleague Vinura will walk you through a hands-on session live. We'll show you how a simple solution could be done using MLOps practices. So with that, let me share my screen. Shalini, can you confirm if you can see my screen?
Yes, Lee.
All right. So this is MLOps simplified. We are trying to explain you the most basic essentials that are required. Although there are few content here that somebody who is enthusiastic can go search and find out. If you want to implement some practices in your organization, you might want to further deep dive, but this is good as an starter. So, first things first, let's look at how MLOps practices are used in the industry. Uh, you might know in the current world, all the application, all the big businesses out there, they're using advanced analytics, AI, machine learning. We are in the LLM world. So Google, Uber, Netflix, Booking.com, all of these big businesses use thousands and thousands of data points to generate or understand their customers and provide services personalized to their customers so that the outcome would be they will earn a competitive edge compared to their competitors, and by providing a unique value proposition to the customers, they will thrive in this world. So next we'll look at to create such a big solution like Google, Uber, that level solution. The industry expects a lot of capabilities from us. All of these mission critical businesses, they demand real world predictions. We wanted to get some data live and give the output. For an example, think about a credit card transaction. You might be doing a transaction, and uh, the applications in your bank should be powerful enough to make a prediction and say that your transaction is a fraud or somebody else has done it. Uh, if some of you have done a credit card transaction abroad without being activating your card for that particular country, you might have experienced this. You'll immediately get a call saying that, sir, did you do such a transaction? So these sort of big businesses have thousands of users, millions of users, lot of models. Development teams are also huge. So we wanted some sort of guidelines, best practices to deliver a high quality solution with less time to market. So today's world, we need to be very competitive, and our solution should go live as fast as possible. Otherwise, somebody else, one of your competitors will implement this and they'll take the advantages. So bottom line is all the solutions should be reliable and scalable to lot of users, lot of models, and lot of development. Everywhere possible, you should look into automate, avoid manual mistakes, and provide the solution faster. So I'm going to discuss about two main topics at a high level. First thing is I will discuss what is MLOps and why we need it at a very high level. Then I will show you uh, what tools or what are the components needed to implement a better MLOps practices. Note that the list is not comprehensive, but it is enough for you to get started in this field. So first thing, I'd like to give a quick intro to what is the difference between software engineering, if there are undergraduates here in this session, or other business colleagues, enterprise colleagues in other domains looking to onboard into ML, machine learning world, data analytics. So the key differences that I see between machine learning or advanced analytics versus software engineering are um, the nature of the work that we do in advanced analytics is very experimental. Taking your attention to the table below, the goal of an advanced analytics task is to minimize a error of something. For an example, think of a prediction. How can we more accurately predict something? How to reduce error? But in a software, we would we will be given the specification. We know for X input, output should be Y. So here it is much more experimental. We have lot of levers to adjust, and we could we there are trade-offs sometimes. We could choose between performance and accuracy, sort of things. When it comes to quality, the output of data analytics project depends on a lot of factors other than the code that you do, the quality of the code. Other than that, um, all the advanced analytics products is based on data. Quality of data is far more critical than anything else for an advanced analytics use case. Um, then there are models created based on data, and there are parameters that can be adjusted by the data scientists or the people who are training the machine learning model. So the output quality depends on all of this. Technical stack also far greater. Uh, if you go into the industry and do a small search, you will find out a big list of tools and technologies that can be used to do a simple thing. Compared to software engineering world, MLOps or machine learning or data analytics has boomed very recently. So there is very great extent to grow and mature. So this field is the area is still getting matured. Um, Finally, I'd like to say the bottom line, the outcome in a software is very deterministic. Like I said, if you know input, you know what should be the output. If it doesn't give that output, there is an error. But in a analytics product, the output keep changing with data, keep changing with the market patterns and all of that. So it is tricky how to serve this sort of an environment. Then quickly showing you the brief process of a solution, a machine learning or an advanced analytics solution. First, we'll start with a business problem. Of course, we are always trying to solve a business problem with a business value. We will get the data required to solve this problem, and we have to clean that data. We will plot the data and see what are the trends of the data. So finally, we will use data scientist expertise and create a model. The final step is to check whether our machine learning model will satisfy the goals. For an example, prediction of sales, future sales, will this model will be accurate to predict whatever the thing that we wanted to predict. So if it is not, we are going back and we do experiments. So this is why I said this is far more experimental in nature. Finally, once you have the best outcome, you need to keep monitoring whether the model is giving machine learning output is accurate. Is there any issues with that? Is the reality is different from whatever is predicted? You need to keep monitoring. Um, all of these steps, I am summarizing up to these 6 particular points. So you have a data set, you need to process it, then train a machine learning model. Once you have a machine learning model, you need to evaluate the ability of prediction, the accuracy. Then you can, if the model is accurate, you can deploy that in production and use it for your application, which is the client I've mentioned here. Next, now only I'm coming to the definition of MLOps. So you can think of MLOps as the end-to-end process of developing an advanced analytics solution. All the steps that I discussed earlier, getting data, cleaning data, developing more, creating a model, training, productionizing the model, monitoring it, all these end-to-end cycle is included in MLOps. Um, in a nutshell, we can say MLOps practices tries to introduce engineering practices such as testing, monitoring, maintenance, all of those into data analytics world. So in the same lines, the life cycle, we start with data, then we train a machine learning model, uh, then we package our machine learning model so that we can deploy it into a production environment, which is isolated. Nobody has access to do any manual interventions. And finally, when the model is running, we need to do some operations to monitor, to adjust some parameters, configure things so that the optimum output is delivered. And after there is a shelf life of a machine learning module, then we might want to go back to the initial stage, get the new data, and retrain the machine learning model and do all these steps from the beginning. So this is iterative. Um, so that I think that you are clear that there should be a clear process to handle this into it. Why MLOps? Uh, I think I have discussed most of these. I'll touch base on scalability. For an example, say that you get a data set of 1,000 records and created a model. Now you want to deploy this into an environment which has millions of records. How do you do that? How do you make sure that your model is capable of making the predictions with a smaller time, and the predictions also has to be accurate. You need to scale your output into a bigger world. So how do you do this? So MLOps practices, if you implement these correctly, is catering all of these components. Next, I'd like to show you an architecture diagram. I'm not going to go into details of any of these. I'm just going to show you what is the complexity. Then in the next slide, I'll show you how you should try achieving these capabilities in your organization. So first, you will start with data. You have to ingest this your business data into an environment, and you should put it in a clean form so that all other applications, so data scientist and your application can consume this data. So once your data is in a clean, consumable manner, uh, we will do the development. So in a separate environment, we'll uh, create a machine learning training job, model training job, and we'll evaluate and we'll see what our model can do. When we have a model that we think is accurate, we can check or cross-validate this and use this in a production environment. So uh, the model you trained in the development environment can be stored in a tool called model registry, which I'll be touching later. Um, for now, just remember that the model that you trained in development environment, we can use it in the production environment, or else we can retrain a new model using production data and use that model for production as well. It is up to your business. If you have your data is similar, I mean, same data is used in development and production environment, you can use the form that I discussed earlier, or else you can use retraining or training jobs so that you can train a new model inside the model production environment and give your client the output using production environment. So once your product or the project is running in production environment, uh, you can't forget it. You have to keep monitoring it. The accuracy and the performance you have to monitor. If you think, if you find
Celine, I think you're on mute. I think you're not audible.
power now,
Yes, perfect.
okay. Shalini, can you point me to the place that you listened to me last? I think model monitoring, right? So I'll start from there.
Yes, Leela,
So
model monitoring.
once your application or the machine learning model is running in production successfully, I said that you can't forget it. You can't let that run without any intervention, like a software deployed in production. You have to keep monitoring it. You have to keep monitor its accuracy. You have to keep monitoring its performance. In case that you find out there is a decay or the model's performance is deteriorating, you have to do a retrain. So once you retrain this, if you think that the outcome is still not sufficient, you might have to do an entire revamp from development environment. So you have to go to development, then again redo the processing. The patterns of the data might change. The features that you have identified might have changed. So you might have to revisit all of those and do a complete revamp of your solution. Finally, once all of this is set it up, you might want to set up a automated environment, automated set of pipelines to do all of these automatically. For an example, once your monitoring component detects there is a decay or a deterioration in the model's performance, you can create a job that will automatically trigger and do a retrain. Not only that, even deploying all of these developments into production environment, uh, doing all of these things can be automated using continuous integration, deployment practices, and then there is continuous monitoring and transformations as well. So today in this session, I'll be discussing on 4 key points. Mainly, I'll be touching on first, I'll be explaining you the importance of code repository, which you might know, you might be using Git or some other thing. So code repository, then the experiment tracker, model registry, and a little bit about a component called feature store, and how you can do automated trainings, I mean the CI/CD pipelines. Um, Actually, before going to that, so this entire diagram that I shown you, you can't go today and start developing all of these component one by one today. So you need to actually come up with a plan how you mature, how your organization mature between having no MLOps practices deployed to having fully fledged end-to-end full automated ML observations. What I'm trying to say is you need to figure out the boundaries where you want to achieve. For an example, big companies like Google, Azure, they are using something called a maturity model. They have already published it. You can go to this link down here. The same thing, the Azure's maturity model is here in the table. So level 0 says you don't have any practices. All the builds, deployments, everything is manual, and even a retraining, everything is manual. Uh, Going to the level 4, you will see that everything is automated. Even model training, the testing of your code, everything is automated. And the running system will be pushing the metrics about how it is doing predictions, the accuracy, performance, all of these, and subsequent pipelines will be monitoring in the backend and do necessary tasks. For an example, retrains then and there when required. So go to these links. If you are willing to implement machine learning operations, MLOps in your organization, try to figure out where you want to be. First, try to figure out where you are right now. You might be in level 0, 1, 2, 3, and determine where you want it to be. Don't just try to go to level 4 from 1. Just try to achieve level 2 and level 3. This is what we have actually done in Octave also. uh, we were continuously improving our practices, and it is showing good value as well. The how part. Um, Before starting this section, the content will help you understand the practical session that my colleague Vinura does just after mine. So just keep an eye on how Vinura is going to use all of these components in his part. I'll be only touching base on the concepts and theoretical part. So you'll be able to catch what actually is, what actually a component is used for in Vinoda's session. So first thing, this is the same diagram I have shown you. So in each of these steps of the pipeline, I'll be explaining you about the code repository, a little bit about feature store, and experiment tracker and model monitoring components. Finally, on the CI/CD pipeline. So let's jump into the code repository. Why you need a code repository and what is it? So if you are a software engineering or a programmer, you definitely have, I think, exposed into a code repository like Git. You can use GitHub or Azure DevOps repos. There are a lot of tools out there, but the fundamental idea is all the code that you do is stored in this particular remote repository. And say that you have a development team of 10 or 20 or hundreds of engineers, all of them will get the code from that single location. So everybody is synced. So nobody will overwrite anyone's code. And the tool tracks changes over time. If you want to go back and revert to a previous version of the code, you can always go and do it. And having all of your code in a code repository enables you to take automated actions based on code changes. For an example, say that you push a new function into your code repository and you want to deploy, you want to create a pipeline to automatically do the testings, then do integration between other components and deploy it into another staging or a UAT environment, do another round of testing using production data. And finally, if all of these are successful, push the final outcome or the new changes with new functions to production environment and start monitoring. So all of these can be automated if your code is in a code repository. So this is a must in any MLOps solution. You must have your code in a repository. Otherwise, this process, the base is always the base is not set if you don't have your code in a code repository is my personal way. Next is the feature store. Now you have data. Your data scientist will play around and visualize your data and come up with uh, say out of 10 or 20 different columns, they will come up with 5 columns that could be used to predict something. So say that you are going to predict your annual sales, next year annual sales. You might want to know your cost of sales, all the things that are counted for the cost of sales, and then revenue channels, all of those. So your features or all of these input parameters are engineered in a way that machine learning training can be ran. So all of these are called features. So there is a component called feature store. Uh, this I think is used in big companies with lot of data. So if you are a startup, you don't you might not need to use a feature store right now, but with the increase of use cases or projects, with the increase of your team and data sets, you might want to look into a feature store. The advantage is all the data is stored in feature store, and development is also based on the data stored in the feature store, and the real-time prediction or the production job is also getting data from the feature store. So it is avoiding a lot of redundant work, and it will improve having a consistent output both in the development and during the production execution phase. One last thing is having all the data in a feature store will enable you to identify any drift in your data patterns. For an example, seasonality effects. So you'll be able to take precautionary actions if you detect some sort of actions here. Next, the experiment tracker. Um, I will straight away go to a view. So what will happen is when you data scientist is playing around with data and running different machine learning algorithms and changing small parameters so that he will get the most accurate model, or he or she will get the best performing model. All of these experiments, we want to store it somewhere so that the developer or the data scientist don't forget about all the runs that he or she has done. So there is a component called uh, model management. So under that, now I'm showing a tool implementing model management called MLOps. Here you can register all your experiments, and you can see here all the parameters given to this model experiment, and the output of the experiment also are shown here. So you can compare between experiment runs and figure out, okay, which one is the experiment that I can use or I am going to promote and use in production. So remember this component going into the model registry. So now you have done the experimentation and you have a model that you think is ready for doing predictions in a production environment. So what you can do is uh, under the same model management umbrella, component number one is experiment tracker. Component number two is module registry. So you can register your experiment in the module registry so that all the live jobs, production jobs, you could have a mobile application, a desktop application, a web application. All of these will use the same machine learning model deployed into the model registry. So it will provide a like your code repository. This is the repository for your modules. So it will have it will track all the versions. So today you will have version one, then 2 months down the line you will do another retraining and you will have version 2.0. So all of these are tracked here. If you want to revert, all of these can be done. Um, Finally, I'd like to show you a bit about CI/CD, which is the pipelines part, which will connect the dots. So, which continuous integration, continuous delivery, these two concepts connects your code from testing to deploying it to a UAT environment and then again moving it into production. All automated. You don't have to do anything manual if you have parameterized all your pipelines correct. Finally, on the continuous model monitoring, uh, I mentioned this in the initial session, initial slides. So you cannot just forget about the model. You need to evaluate your model continuously and see whether there is a drift between predictions from the time that the model has been trained and to the current time, maybe after 2 months. So you might need to check on a lot of things, quality of services. You might have to check latency of the model, so and then the throughput with the model is giving a accurate output very fast as required by the application. Finally, at last, I must say that MLOps practices is not a thing that you can just define by using tools or services that are available in your environment or your cloud that you're working on, be it AWS, be it Azure. It's a culture and a practice your team that you work in has to embrace the way of working under MLOps. There are you might have manually done, you might have gone to your database and got the data, then you might have ran a IPython notebook and created a machine learning model. Now with MLOps practices, all of these are getting controlled and then logged. All of this has to be embraced by your team. Okay, this is the new way of working. You need to work with these practices. The benefits should be clear to your team so that they will embrace. MLOps with data, model, and DevOps practices and pipelines has a lot of components, and these are evolving. These are every day evolving. So you might want to pay an attention to what is happening in the industry, what are the big players are doing. With that, I think that is it for my part, Shalini. Over to you.
Thank you, Lynn, for your very insightful presentation. And I hope the audience also has a clearer view, a few of the crucial fundamental concepts that Lynn was explaining. So I would also, again, before going into the next segment of our session, I would like to encourage our audience to also send in any questions that you may have that you would like to ask Lean or the next panelist that we will be bringing into the conversation. Please feel free to send in your questions so that we can get to it at our Q&A segment. So moving into the next segment of the webinar, I would like to quickly move in to our next panelist, who is Vinura Pereira. He is a seasoned machine learning engineer and consultant at Octave, and he will be doing a live hands-on demo session focusing primarily on tracking experiments and models, use of ML flow to change models and production, and basing on few of the concepts that Lean explained earlier in his presentation as well. So, Vinura, could you also tell the audience a bit about your expertise and your experience in the field of MLOps, and you can start off on your hands-on demo.
Okay, thank you, Shalini. So I have been with Octave for last 3.5 years. First, I joined here as associate, then worked my way up to a machine learning engineer. Now we have gone through so when we started, we have been no MLOps, nothing, no DevOps from there to all the way up to automated MLOps level. So that has been a good journey, and I have been part of that along with Lean. So I hope that I can give some experience and also show you guys how this can be done in your organization and get you into a very practical session of how to get a simple solution to MLOps and integrate MLOps to a very simple solution. With that, let me get started and let me share my screen first as well. Just give me a second. Can you see the screen now, right? 1 second. Is the sharing working?
Your screen is not visible. Vinura, maybe you could turn it off and turn it back on.
Yeah, yes. Okay.
Yes.
So I think you guys can see my browser. We'll start from normally how a data scientist get like normally works. And so normally most of data scientists used to work on a let's say a notebook. So we have a Colab notebook most of the time, like normal IPython notebook most of the time to create our experiments or run our experiments. So imagine this is our Colab pipeline that sorry notebook that you're using. It can be a Colab notebook, it can be your normal Jupyter notebook, anything. And that is where we start. Normally, that is where most of the data scientists start. So to emulate that, I have my notebook as well, where it's on Colab, and it has all of my code. And this is a pre-done code. What I'm going to do is I'm going to create a and run it through a MLOps and see you guys how easy it is once we implemented MLOps to get it from this to a working app like let me open this one. Working app like this on Streamlit or some like where whatever your end goal is. So I want to go from this to an end goal like this, where you can just upload a photo and see whether it's a cat or dog. It's just classified. So first, let me install the packages that I need. So right now I'm using PyTorch and MLflow for this. And for that, we need a MLflow server as well. I have my MLflow server up and running. We will. So what you have to do is you can run the MLflow server locally. You can run a MLflow server on cloud. This is where we do all of our experiment tracking, register our models, send models through staging to production. All of that happens here. But yeah, so now this has installed. I'm going to connect these things together. So we can just simply load your MLflow and then set MLflow tracking URI where this MLflow is. I'm simply gonna this server. So it's a very simply set MLflow set tracking URI where once I give the URI, it will start communicating with this MLflow server. So at the same time, we need to connect this into a GitHub as well. That is where all the versioning happens. So if I go back to my Colab this thing, so to get started with, I have the Colab. Then I need GitHub as well, GitHub or a code versioning repository where I get connected to. Then I also want a ML4 server to track my experiment. So let me, let me move this here. So it will look like this once just a minute. Just okay. I think I lost you guys for a bit. Okay. So I have my experiment tracker here, where I'm going to connect my experiment tracker Colab into the experiment tracker using that mlflow.uri method. So whenever we do something, now whenever we do something in a Colab, it will get connected to this mlflow server. And whenever we save something in the Colab, it will send to the GitHub. To demonstrate that, what I have done is basically connected my Colab with GitHub. You can do it using pretty much here, open a notebook, and it will give you option to go to the GitHub, include your URL, then you can just connect it very directly. It's a very simple process if you want to use GitHub and Colab together. Else, you need to create a repository on GitHub. Let me go to my GitHub. Yeah, okay, let's see what's again. Come on. Let's go to the repositories, webinar. So otherwise, if you are doing this locally, you can just pretty much create a new repository, go to code, uh, copy this and do a git clone as you do normally a git day-to-day life. normally when you're doing a software engineering, I think all of you know about Git. So we are not going to step into Git and actually go through these Git commands and everything. You can do a simple Git clone and get your what you call code into your personal computer, and then you have this thing like this as well, the same code. But I'm gonna present you it on MLOps in Colab. So now we have done these two. Sorry. Okay, now guys hear me? Yes. Okay. Okay. So now we do have this connected, these two things connected. Now we can move on to the other part. So in this, for this, what we have done is to do this demo. We have listed, like we have generated, collected some of these cats and dogs data sets. This, each of these links go to either cat or a dog. And we can use that to download these images. I have created this simple function to download these images. And once you run this along with the other two, we'll be able to download these photos into our photos folder as mentioned in left hand in the left, this left pane. So I have already downloaded it because it takes around like 1 to 2 minutes to download it. So it's like 1 minute here, 1 minute here. In to save time, I'm not gonna run these two, but pretty much we can just download these links directly into the column. Now that's the data gathering part. And since this is not about data gathering, that is why we are not going into details here. So now we have two different classes. One is a dog and one is a cat. But yeah, if there's like anything corrupted, we can just remove it by running this here. What this does is if it's like under 20 kilobyte, it will just delete it. So that is like, data cleaning, all of that. So I'm going to get into the other parts where actually we are going to start tracking and everything else. So here I'll again load the torch models, everything that we need. Then we run the pre-processing. Here we can actually do our pre-processing. We have this, do some transformation. This is like standard PyTorch commands where we transform our data into the format that we need, then normalize it, and then create a data set from the images. And then we split it into train and validation sesa. And then we create a train loader and a validation loader that we can use to train our data model. Just going to quickly go through this to get into a proper ML flow stuff. So now this is where the magic happens. So in order to track our model, MLflow gives a very good set of a good library. MLflow natively support most of the libraries that we use, and we don't have to do any extra coding. We just need to use just MLflow start run. So what this would do is create an active run to the parameters that we have mentioned here. I created a new experiment called MLflow experiment. So this is where all of my experiment gets saved to. And I have saved that, set this as an active experiment. And here we start the tracking. So once you put ml4.start run, it will start tracking whatever that we do here. So I'm going to define a model. And then I'm going to create the optimizer for the RSNet. Just to kind of give you an idea what I'm doing here. So there's a model called ResNet for images. And what I'm going to do is I'm going to optimize it to predict cats or dogs for this example. Now I have given LR as 0.03, momentum as 0.9, then the cross entropy loss as the criteria. And we have an optimizer, STG optimizer. And I'm going to just run this. Now, if you look at here, I have mentioned the device as like we are using CPUs here, since this is a CPU based environment from Colab. And then I have number of epoches, and this will take around like 1 to 2 minutes to run. Meanwhile, this is running. I'm gonna go to the ML flow. Remember, I talked to you about here in very top. We are going to define what's the our experiment is. You can define any number of experiments. So it's just simply adding a new experiment name and where you want to save your artifacts. How this works is, whenever we want to run our experiments, let's say one um, one problem. We can group it by saying, okay, I'm going to run this problem and I'm going to run 10 different experiments. I want to track them all together. So that will be all in one place. That will be here. Now, I just ran that one, right? It started recording here. It says this, I mean, I did not add a run name. So it have given it bold mule 203, created 1 minute ago. And the source is a Colab notebook. That is that is the source. And let's see how far this has gone on. Yeah, still running. So we have loss of 0.75 and still running. Yeah. So let an accuracy of 80.89, and I'm running for 3 times. Number of people are 3 times. So I think this is the first run. We need to wait for 2 more runs. Meanwhile, let's go here. So if I go into this, it's nothing is populated yet because this run is still running. So we need to wait till this ends up. Okay, so still here. This will take around like 2 minutes. Right. Okay, I'll come back to the architecture and explain a couple of other things till the that thing runs over. I can, yeah. So to recap, we started with a Jupyter notebook or a Colab notebook. We connected with the GitHub to make sure that we have a method of tracking our code. Very simple, the standard GitHub, standard code versioning. Then one extra thing that we did was connecting this into this experiment tracker, where it tracks what's the source, what's the data source that we use, what's the file or the notebook that we use, the name of the notebook, where it is, and it will also track the parameters that we that that we used for it will automatically get tracked. Yeah. And apart from that, okay. Yeah, I think this, sorry. Okay, so I think this, okay, still running. Apart from that, it will also track anything that else we want to add. Like, let's say if you want to add custom parameter or custom tag, we can also add that. Everything will be saved here. So you don't have to do it manually. Because I have seen data scientists like, trying to figure out, okay, what the run did I did 10 a.m. in the morning, around like the evening, and you can't really figure it out, and you are running again. Sometimes we get a good results and we are trying to figure out what was the parameters that I used, because we thought I can get a better results than that, and really did not give any attention to the parameters that used in that particular run, and we went on. That has happened to me, and I have seen that happen to everyone else as well. So a tool like MLflow completely helps you to keep track of everything that you do. Let's go back to the code and see. Okay, now it has completed. So we had, I think, the first run 88% accuracy, and the okay. So with to log the other parameters that I use, I can do like mlflow.log parameters and give the things that I want to track. So I'm just going to run this and in the mlflow run. So it's what this gonna do is it's gonna send the parameters that I want to track, and also it will send the model that I want to log as a cat and dog estimate model, and it will also log the metrics, accuracy, trend, loss, and everything, and then end the run. Now I can run this with different parameters. I have done this previously in the here, so just to avoid running this multiple times, I'm waiting for waiting it to finish up. Yeah, so if I go back to MLflow and go to my MLflow dashboard, there's a one that I created, ML experiment that I created, MLOps. Now I have ran like around what 1, 2, 3, 5, 6, around 9 experiments, and this is the latest one. If I go here, go into that, I can see the parameters that I used. I can see the metrics the train loss and the validation accuracy. I also have my model and the data it used, and I have the model here as a as an artifact. So this is pretty much how it would look like, and it has taken around 7 minutes to run the whole thing. Uh, and and we can add like more and more. Let's give a name. Uh, say it's 13th. You can just give the date, like when did I run for this webinar, and I can just edit. So likewise, I can keep adding tags if you want to organize it. There's a lot of features, and uh, this is where we can like add other descriptions. Like I can add a description, and if you want to populate other things, if you had like any thoughts, you can add this. There's a lot of functionality here. Now, let's say I want to compare my results with the older ones. That also possible. You can just go to MLOps experiments, and I can just select two. Let's go to the charts. Just say I want to select these two, and I want to compare this. So in the first run, it says 0.91. Then the second run, it again what 0.108. Like that's in the 95% accuracy. And let's read one more. What other names we had? Crawling and Vault. Okay. Let's configure this as a step loss. So we have two data points saying the what we had like on 0.92 and 0. Likewise, you are able to pretty much when I ran around 3 o'clock, it's around 0.10. Likewise, you can just compare what you want. Okay. So this will allow you to compare any metric that you like, which if you have logged it. So this is a really good feature when you want to select a model that you want to bring from your experiment phase into your model phase. So now let's do that. Now I think this ball mule has one that I ran has a good accuracy, which is like 95%, and I can just register this model into my image classifier. So either you can create it, save it as a new model, or you can save it as an existing model. So I'll give it as name as a image classifier, and I can register it. Now that I have registered it, if I go to my models and go to image classifier, this is the latest model that I registered. Previously, I have registered 1, 2, 3 models, and one is already in production. and other two are either like in the non-stage. When we first register a model, it goes to stage none. Then we can decide what you want to do with the particular version of the model. So if I click on the version, it gives this dashboard where it says, okay, what are the tags? If it has a tag, if there's like any description, and it also gives this staging. Like right now, I can transition from none to staging and stay okay. And it also give if let's say I want to go back to what's the experiment or what are the things that I did, I can just click on this. It will directly go to the parameters, metrics, tags it has, all of that. So let's go back to the model. Yeah. Now we have one model in staging and one model in production. Now, if I go back to my diagram here, so we added the model registry component as well. So sorry, we have this from experiment tracking to registering a model. Now we have those two. Now what you're going to do? So we need to, like, let's say we want to show this on a Streamlit app, like, get the results on a Streamlit app. So what you're going to do is we are going to deploy a Streamlit app. Sorry. And Streamlit app. This and we can have only the model artifact getting the model artifacts, getting the Streamlit getting the data from the model artifact or the inference from model artifact. So how can we do this? If I go back to my code here, simple Streamlit app created, which uses tracking URL that we input and model name as image classifier. And we also set a stage. We can stage either non-stage in production or archive and use that model. This is all the code that I use for my Streamlit tab. Oh, sorry. I need to change the, okay, sorry. Let me share the screen again.
So do give us about a minute. I think the winner has run into a bit of a technical difficulty. Please bear with us. Give us about 1 minute to have this sorted.
Okay, I think everyone can see my screen again.
Yes, Vinura.
Okay, so no, earlier I was only sharing the web browser, so I started sharing the thing now. Okay, so as I was saying, I have this Streamlit app created, and this is directly using connecting to the ML flow and not everywhere else, and it's getting the model from ML flow. We are not loading a ML, let's say binary model. We are just using an API that is exposed by ML flow to get the model and do the inference. So if the code is all the code that I use to create this app is only this, and we are using ML flow, and from ML flow we are registering saying, okay, when when someone populate give a tracking URL, which is the server URL, and a stage, use those two to get the model and do the inference. How would happen is, so I need to give my server URL. I mean, you can just hard code it for this purposes. I just use, like, if anyone want to use this as a their own test, you can just get it from my GitHub and use it. So you can just, I haven't hard coded anything. I have just put it as a user input. So the reason why I didn't hard code it for anyone to use it, so you can just have your own Streamlit app, enter your tracking URL, and then let's say if I go back to and just add a stage and do some yeah. So right now I have two versions. One is in staging, one is in production, and I don't have anything in. If I go to version 2, we have, yeah, staging, and I don't have anything on archived. So just staging and production. And if I go to Streamlit test, say production, this URL, and let's give some photo to this thing. Yeah, yeah, that guys looks good. You can upload it and ask it to classify. So what happens is when I press classify, instead of loading a model and doing it, it will ask MLflow server, okay, for this URL, for the defined model name, just give me the model and use this, send this image to the model and classify and give me the prediction. So that's what happened. Now we got the prediction as a dog. So if I go back to the code to give bit of a clarification here, what happened is I have tracking URL, which is this user. And once I have all of them, and I have hard coded of the model. So this image classifier name is what I have added into under registered model. This is the, and if I want to create a new model, I can, let's say, image v2, let's say specifier v2. So it will create another model. So like that, you can have like bunch of models, but right now I'm using image classifier model. So use that. From that model, the stage that we enter. So from that image classifier to whatever in this production stage, we are going to use it as, sorry, whatever in this production stage, we are going to use it to inference. And using all of that, once I send submit, it will ask, okay, what's the prediction for this given image? That's it. And if I go back to my this thing, now we have GitHub, we have Colab, we have experiment tracker, we have model tracker, we have registry. And this is a very simple way of using MLflow server to track your experiments and manage your models. Let's see. Okay, let's go to here. And let's say this is a production, and let's say this is just one thing, right? The way that you can use it, like way that you can use it, let's say you have two different you also have one for testing. And these three things, and I can use for this one, I can use let's say what I want to use. Let's say from this up we are using the non-stage, and for this we are using staging, and for this we are using the production. So like this, you can simply separate how you're gonna use staging layers and everything, and have separate for your development, for your staging or UAT testing, and for your production. And then let's say you want to add some testing, you can bring in automate like testing when you're committing your code. And lastly, if you want to do some automated retraining, we can also create this and connect it back to model registry. And I'm gonna extra layer saying instead of right now we have 2, right? I'm going to add the and it will automatically run a pipeline and save. So it's the same code. It's just that I'm going to add a third one saying cats, dogs, and cars. So if I go back to my code and if I go to train here, it's the same code that I used, which I'm using the same MLflow server, which is coming from here. Let me copy that. If I have changed it, copy that, paste it here. I think it's the same thing. Yeah. Okay. Yes, it's the same thing. Then we have MLOps experiment as this. Then here we are going to add this cars. I have already have the data list here, supercars list of cars here. And it's going to download those and set number of classifiers as number 3, and it will download all the images. Then we are going to remove anything. Let's say when you are downloading these images, sometimes those are corrupted. So let's say roughly if it's under 24 kilobytes, we are just going to delete the file and just do the same data transformations, model validations, and everything. And yeah, lock the model and end the run. Let's say we have anything else. Yeah. So I can just commit the work that I did. Let's say new model run. I can just please get okay. So go back to my this, refresh this. It says dev branch had new push 10 seconds ago. I can create a new pull request back into the main branch to add cars. Just going to create a pull request. So I haven't added anyone to like what do you call? So I'm going to merge it without bypassing the protection. I have added like I have added like one more person should approve this, but I'm going to bypass it since I'm admin on this repository. Okay, now if I go back to the code, the main branch, everything has merged. Now if I go back to my actions here, it's running this training pipeline where it's pretty much just going to run the whole of this code. That's it. And what this code does is this do the automatic pre-training. GitHub, it will take like 3 to 4 minutes. So some automated retraining and registering it the model. So I'm not going to edit any of this. I'm just going to put it on there here. And after that, once it completed, it will show up here saying, okay, there's a new the new cars with new model with cars and everything. Yeah, that's like the overview of our practical session. If there's I think we had some questions as well on chat. I think we can take the questions up while this is running on background. Shalini?
Yes, Inura. So we did have a question coming in from Maza's side. I think, Maza, your question was answered by Upul. So I hope that the answer that you were looking for is provided by Upul. He is also one of our esteemed team members at Octave. So let's, and there is another question from, um, uh, I'm not too sure what the name is, but there is a question that comes in saying that I just want to know, machine learning is related to the big data. So yeah, I think Upul has also responded to it. And again, we had another very interesting question coming in that asked from Dilshan. He had a question on how he can prepare for an internship to join Octave and what the requirements are. And since Lean and Minura, since you have had experience in this journey of coming into the industry, maybe you can impart few of your experiences here so that Dilshan and many of the other guests also who are participating in the webinar can also understand what is required for you to prepare for a career in MLOps and come into this journey.
Sure. Okay. So, a couple of things. First, get your basics right. So that's the number one. I like what you have to do is get really familiar with Git. So code versioning, get your basics right. In MLOps, MLE, whenever you like, just forget about MLOps, MLE, software engineering. Get code versioning and Git basics right, and learn about CI/CD pipelines, because those are like the basics even for software engineering, even for if you are MLE, even if you are a data scientist. Those two things will take you a long way, because I have seen even myself when I came to John Care's, when I joined in, even I didn't know. I had to learn from scratch. So if you know those two only, you will have a very, very big advantages over anyone else. Because in our universities, we don't really learn that part. That's number one. Second part is learn a bit about architectures that you can look down. There's different ways of implementing MLOps, getting everything to production, like those things. Like just get an idea of if someone asks what is a feature store. Don't like that's a component of that big architecture. You don't have to know in depth how to do it, but just to have a general idea about, okay, if someone say a buzzword, make sure you know what that is. Otherwise you will be like, okay, what that is. Don't be that person. Just read new trends coming up. And also because a feature store is a very new thing, maybe like 2.5 years, 3 years. Even I only got to know like 1.5 years back when we started working on it. Things like that. Anything else to add, Lee, from your side?
So from me to add to Vinura, I'd say that just be passionate. Uh, if this fits your passion, then I don't think nothing can stop you. So just pursue a career like Vinuda said, you will hear things, you will see ChatGPT going out, now skyrocketing these days, then lot of Gen AI tools will come up. So you might, if you have the curiosity to see what is happening underneath, only that you will be able to understand what is happening, how to do it. Then if you are passionate enough, just go ahead and try out few things like we did today. It is just a Google Colab notebook, which is free. You can go experiment with your account. Nothing can stop you. Just go to internet, search for an example, start doing that. So that'll help you get started. And saw a question from a person looking for an internship. What I'm telling you is if you are passionate enough, if you have tried something, just go ahead. Don't worry. Nothing can stop you.
Great answer, Lean. So I think there is another interesting question that just came in. Uh, this is from Shehan. He is asking, given that your webinar focuses on MLOps, that he's curious about the role of big data in Octave. Would you be open to discussing how Octave leverages big data, privacy, and security?
Okay. So this topic is a topic that I should be careful in discussing. That is the first thing. So in terms of Octave, not only in Octave, I think by working at Octave, what I have experienced compared to my previous experiences also, we can work with fully anonymous data. You don't have to know a customer's NIC, you don't have to know a customer's mobile number, you don't have to know it is or her name. So you just have to have the journey of data related to the customer's journey to do an analytics. So you just, I mean, if you are a company doing advanced analytics, the privacy is utmost. You have to pay your utmost care for the customer's data. Right now at Octave, we don't touch anything that has a personally identifiable information. Even the tools that we use today is governed by all of the security platforms that we have laid out. Nobody can't bypass those. All of these data governance principles, model monitoring governance. Uh, these practices are set up so that by accident, if some engineer has done a mistake, how we can prevent that from happening. So basically, we don't use PII data so that the risk of exposing some critical information is very minimal or basically none inside Octave.
Just to add second, like another thing to that, I think Lean focuses on the second part of his question. Would you be able to privacy and security? Now, the first part is I'll give you a very high level understanding of we use big data here, or the data that we have about our customers and everything. Since Dean explained about the PII data and how we are not using it, I'll explain how we are, what are the things that we do in essence. If you look at a vertical or industry like retail, there's a set of standard things that you can do. You can optimize your stocks. You can optimize your transportation, how you transport your good. How can optimize how much, what are the discounts that you can give. These are very standard use cases in the industry. This has been happening even before ML came into play. This has been happening when the analytics was in place. What ML and AI, we are doing it here. We are augmenting that process and optimizing it further using these AI and ML technologies. And if you want to really look into Octave, if you want to look at an industry, it can be beverages, it can be retail, it can be leisure, it can be any other industry. There are standard set of use cases. You can just do a simple Google search. Let's say, what are the use cases for X industry that I can use with MLOps? You can even use ChatGPT, and it will give like 10 or 20 different uses that you can do. What we do here is we take one standard use case like that. Let's say optimizing our let's say promotions. We take we come up with a hypothesis. If we use X algorithm to X, Y, and Z, what will be the outcome? We come up with a hypothesis. We try to validate it. But how we validate it is we run a pilot. We validate the results and try to predict if we implement this given solution, what will be our gain or the outcome. And if that outcome is big and it's compared to the investment that we make, because all of this has a cost element, and for that cost element, the outcome makes sense, we implement it through keys like that. How we use our big data here.
Great. Thank you, Inuran. We also have, at the interest of time, I'm very sorry, we do have about 2 more minutes to run through our questions. So we do have Mazar. He wanted to get the opinion of his question from the panel also. Mazar, would you be able to unmute yourself and ask the question directly from the panel?
Sure, can you hear me?
Yes, you're audible.
Yeah, okay, cool. Hi, I'm Mazar Say. So I believe like you can use DVC for data versioning, but in case like in certain scenarios we can use DVC also for model experiment tracking and data versioning with the help of like Git. But it's more I believe it's more better than using MLflow as well as DVC, because using one tool helps you to reduce the switching between windows. And also what happens with MLflow is they save your model experiments in a centralized server, which you don't know where it is and like what's stored. So if you can like if you're using a DVC, you can just easily store in your local server, and this helps in two ways between switching between uh, Windows and as well as like storing in a like local server than a centralized server. I just want to like know what are your thoughts and like whether using DVC alone is better or like combined, and also you at what level and organization would like to use AWS SageMaker compared to open source tool like Kubeflow. Like what are the key considerations organization should give when considering between these tools, between this tool like AWS SageMaker and Kubeflow? Yeah, those are my two questions.
The first part, I'll take the first part. Yeah. So to answer your question about like multiple tools or single tool, this actually comes down to your organization and your organization needs and how big your organization is and how mature you are as an organization. For us, and also the other tools that we use, because all of these tools, let's say if you're using something, if not a managed service, you have to maintain in maintenance. That itself incur a cost, right? So if you are an organization that you can actually have separate teams managing it your own, are willing to have that capability plus having this maintenance and everything, that is where I think the decision comes in as an organization. And two tools, one tool for me personally, it comes down to what's the capability that you need from it. If the tool A has a separate capability that I really need it and the B doesn't, sometimes you might have to use these specific tools. If you can um, tick all the boxes that you need for your organization, you can go with one tool. Because in the end of the day, what we are looking data version control, model tracking, and model management. If you can tick the boxes that you want, and if you can do it from one tool, I think it's go for that. And as a your organization, let's say you are using something like Databricks or something, and Databricks also gives a managed service with their Databricks uh, as a service. And if it's already hosted, you don't have to do anything. You can just start using it. And in a because of a service that exists for us, it's very easy to use that. And with that, there are other things like Delta Lake, which has inbuilt data version control. So it's really depends on what are the requirements that you have, and if you can tick those all the requirements from a single tool, go for it. And if you want like very specific requirement from another tool, you will have to use that. And when you use two tools, you will have operational costs that associate with that, even for single tool. So you will, I think it's a you have to go through everything before deciding on what you need. That's a very specific requirement of that organization. Yeah.
So let me look into the next question, the SageMaker versus Kubeflow. In my personal opinion, there are few concerns that you have. SageMaker or any other tool that is fully managed by a cloud provider versus a open source tool has its own challenges, right? When you're using open source tool, you might have to have separate. You have to have your skills in your organization so that they can maintain it, they can run it. Any issues can be taken over and so resolved faster so that the impact is minimal. Versus a past solution will be fully managed, right? So that is one concern. And the next one is cost. You might have to, most of the times it is a pay-as-you-go model, but free tool no charge, right? So that is one concern, but it like the same answer like Vinod gave depends on the expertise that you have in your organization. If you have a dedicated engineers platform team that can take care of a tool which is deployed versus a PaaS solution which is easy to manage, is actually a choice of view. For an example, here at Octave, we tried using different tools, but we are truly an advanced analytics company, right? So investing lot on maintaining a platform team, a big platform team, or a team or a big server set, which is running. Maybe you want to run a manual server just to host something. Is a cumbersome task for us. It is far more easier to purchase the PaaS solution and focus on what we do best. Data analytics is what we have practiced so far. So that is currently working Masar for us. And it is a organizational decision I think that you have to take if you want to go into open source tool deployed on-prem or on top of a VPN sort of a setup.
Yes,
That is one.
thank you for that answer. I just want to know how it's done at Octave and like how the organizational approach is towards these tools. Thank you. I got it.
Great. So unfortunately, we have run out of time. We've actually 5 minutes overdue timeline. We have had some few comments and questions regarding big data, and there was a suggestion as to whether we can take it into consideration on a webinar after this webinar. So we will keep you posted on that. I'm so sorry. Unfortunately, we will not be able to take any further questions. But I sure hope that Vinura and Lean were able to answer the questions that you had. And as we wrap up today, as we wrap up today's session on machine learning ops, I would like to thank each and every one of you for joining us on a Tuesday afternoon after lunch and sparing your time. And thank you very much again for joining us. Remember that the world of technology is ever evolving, and embracing machine learning ops is also a step forwards towards staying at at the forefront of that innovation. And I encourage, I think I'm pretty sure Lean and Vinura will attest to it. We encourage you to continue exploring, learning, and implementing these insights into your work and actually inculcate them within your organization as well. So a big thank you to our incredible speakers, Vinra and Lean. Thank you very much, and to all of you for your thoughtful questions and active participation. I am very sorry. I again want to apologize over the fact that we are unable to answer the remaining questions that was sent to us. But we will definitely take it into consideration when we arrange our next webinar. So don't forget to check out our LinkedIn page for upcoming webinars. We will keep you posted regularly, and we will have more engaging discussions on emerging technologies. So until next time, stay curious and keep pushing the boundaries of what's possible in the world of technology. Goodbye and take care. And thank you very much again.